Hello, 1.4, Arguments and Rules of Inference. Okay, so here I'll just sort of read this yellow stuff to you. You could read it, of course, but consider the following sequence of propositions. So first we have the bug is either in module 17 or in module 81. The bug is a numerical error. Module 81 has no numerical errors. Assuming that these statements are true, it is reasonable to conclude that the bug is in module 17. Okay. So what's going on here? So the process of drawing conclusions from a sequence of proposition is called deductive reasoning, right? The given propositions such as these three, 1.14, right? Those are called the hypotheses or premises of the argument, and this is called the conclusion, right? Conclusion. So, all right, so here it is in formality. So an argument is a sequence of propositions written in this form, right? Or written this way. The symbol with three dots there is read therefore. And so the propositions P1 through Pn are called the hypotheses, right? Or premises. And the proposition Q is called the conclusion. So we're going to talk about this. So there are ways of giving arguments to make conclusions from other premises, right? And here's an example, I guess. Let's see. Let's determine whether this argument, blah, is valid. Okay, so what is the game? Okay, so here's our first solution. We consider the truth table for all the propositions involved. Okay, so we do that. We put a P, a Q, all the possible truths that we can put down here, and then we calculate. So here we see P implies Q is true in this case. It is true in this case. False in this case, right? True, false implies false. False, true, those are both true, etc., etc. Okay, so we write down this truth table. And you can observe that whenever the hypothesis P implies Q and P are both true, then the conclusion Q is true. So how do we observe that? So you look at this, this, and this, and now let's see. And now we're looking at P being true, so that would be this one, right? Okay, so the only one that corresponds to that is this one. Okay? All right. Well, the second way you can do this is you can avoid the truth table and do it directly. So you say to yourself, suppose that P implies Q and P is true. Well, let's see. Then Q, it says, must be true. For otherwise, P implies Q, right, would be false. Therefore, the argument is valid. Okay, so you can also just sort of reason it out as long as you're using proper reasoning. Okay, here's some rules of inference, which have all kinds of fancy names that you don't have to memorize, but let's take a look at them and see if they make sense. So if P implies Q is true and P is true, well, then Q is true. We know that that's valid by just knowing how it's possible for P to be true and P implies Q, okay? Additionally, if P implies Q and if not Q is true, right? Well, then the only way that can happen is that if not P is true, okay? Because if P were true, right? Why do we want to believe this? Oh, if P were true, that would imply that if P implies Q are true, let's see how we reason this out. If P implies Q is true and P were true, that would automatically imply that Q were true. But here we're given that not Q is true. So you can go through these like here's a rule. If P is true, then we know that P or Q is true, right? Here, if P and Q are true, then you know P is true, right? These are all fairly straightforward. We know if P and Q are true, then P and Q is true, okay? So here's one. If P implies Q and Q implies R, then P implies R. So these are rules of inference for propositions. Okay, then there's more examples. Let's see. I'll go through this example here. So let's okay, let's do this. Let's represent the argument. So here's the thing. So the first proposition is that the bug is in either module 17 or in module 81. The bug is a numerical error. Module 81 has no numerical errors. Therefore, the bug is in module 17. So this is the one that was given at the beginning of the section, as they're saying here. So if we let P be this statement, Q be that statement, and R be that statement, then the argument may be written in this form, right? Okay. And so how can we see that that's valid? Well, okay, from P implies not Q, right? That means that, and R, so if you take R and R implies not Q, we may use modus ponens to conclude that, not Q, okay? Well, if not Q, right, so that means that Q is false. Well, if Q is false, then looking up here, we must have that P is true, okay? So that's kind of how this all happens. All right, and that's it for 1.4. Yeah, if you have any difficulties with any of the exercises, definitely read through the text or redo this video or use this as a resource, whatever works for you. Okay, thank you.